Um, and the width is 1.5. So in other words, if we go back to the beam deflection lab and look at that first 2x6, you can see it's oriented vertically. So the height is 5.5 and the width is 1.5. So that's where this row of information is coming from, right in here, the height and the width, okay? It's oriented vertical, horizontal, vertical, horizontal. You can just write those in. Now, the cross-sectional area, this is where I want to see you put an equation in. So you're going to have to hit the equal sign, and you're going to have to click on this cell, and then type in a little multiplication or asterisk, and then click on this cell, and then hit return, okay? And then what you're going to want to do is click on that cell once, and we want to repeat that equation for this cell, this one, and this one. But we want, for this one, for example, we want the numbers not coming from over here, but for here. And for this one, we want to calculate this based on this number and this number. Same for this one, okay? And the way we just do that is we want to copy these. I'm going to actually delete all these for a second. This is where you'll be. And all you need to do, you have an equation in here, and we want to replicate it across here for each one of these sets of numbers. So all you got to do is go over to this bottom right corner so it turns to a little cross, click down, and drag right while you're holding down. And what that does is it copies that equation across for you. You can see here now I'm using D11 and D12, which is, this is D11 and that's D12. If I go to this one, it's F11 and F12, okay? So that's the first calculation you should do. It's the simplest, just the height times the width. Now, moment of inertia. You can see it's a little bit more complicated equation, but basically all you're going to do is you're going to hit the equal sign, and then you're going to do a parentheses and a parentheses here, and this is where you're going to click on B12, which is the width, right? Here's our moment of inertia calculation. Width times the height cubed, so width is B11. The height is 12, so you can see here I'm multiplying the width times B11 cubed, which is the height cubed, and then just doing divided by 12. And that'll get you the number here. If you go back to the beam deflection lab, 20.8, you can see here we've calculated that perfectly. Okay? And then what do we do to copy that right across? We just grab this little cross here and hold down and drag. And there you go. You've copied that equation across all of those. And then we just got to go to our beam deflection. That's probably the most complicated. But again, the beam deflection equation is right down here. So we're going to say equals, click on B21, right? B21 is the load. That's this F force. So we can click on B21. And these dollar signs are kind of important, and we'll go over that in a second, but I would put the dollar sign, so you're going to go dollar sign B, dollar sign 21, and multiply that times dollar sign B, dollar sign 19. That's going to be the span, right? Because that's the second part of our equation is this L cubed. So the span, which is 144 inches cubed, and then we're going to divide that by 48 times B20, which is E, okay, modulus elasticity, and then times B15, which is our moment of inertia, okay? But once you hit return and you get 0.5 for this first one, we can't simply take this and drag across like the others. Why? Because these numbers are going to stay the same for each calculation, right? The modulus is the same. We calculated the modulus of elasticity. It's an inherent property of this type of pine wood. Doesn't matter about the dimensions, remember. So we're going to use the same modulus elasticity for each one. The same span, the same load. So if you want to take this and drag across and keep these cells in the same place, and just change the height and the width So as we discussed, when we want to calculate this um, beam deflection, there's going to be some variables like, or in this case, I guess they are variables, but they're going to remain constant through each one of these calculations. So we want those to stay the same as we click this equation and drag it across. So the way we do that, when you want to hold a cell constant while you drag across, you just surround the column, which is the letter, and the row, which is the number. You precede them by a $sign. Okay. So we want to keep B19, which is the span. We want to keep B20, which is the modulus of elasticity, and we want to keep the load or the force constant, which is B21. So you can see I've surrounded those with these, or I've designated them with these $signs. So that means once I click here and get the cross and hold down and drag, you'll see that, like, let's say I take this one, for example, it is using D11 and 12. Well, sorry. It's actually using D15, which is the moment of inertia, which we calculated, okay? But you can also see it still use D21, B21, B19, and B20, okay? So that's essentially what you have to do there, okay? So you're going to fill in this whole graph. The other thing you want to do is the way you can put a grid around this, basically these grid lines, is click here and drag across and highlight your whole table. And then you can come up here to the borders and you can select this all borders, and that'll put borders around the whole thing. If I wanted no borders, I could go clear borders, and you can see I have none now. That's how you'll be, but you'll basically just click here, drag over, and then go click on here and select which one you want. You can actually select you could select a different border color. You could select a different border width, okay? So for example, let's say I wanted to go and for right now, just use the thin border width and put a border around this whole thing, right? But then let's say I wanted to highlight this whole thing and I wanted to use a thicker border just around the edge. I could come here, select a thicker border, and then go to this one, which is the outer border. And you can see here that's going to put a nice thick line around the edge, okay? Okay, the last thing you want to do is we want to build this graph. So basically what I did was I hid this little table behind the graph. So you're going to want to create your X and Y variable table here. And so you can see here I have beam deflection is my Y and moment of inertia is my X. Okay? So you're not going to have anything here, all right? So I'm just going to move this out of the way, and you'll have a blank spot. But basically, you're going to put, you're going to come in here, and you can just set up a table. You can say moment of inertia, and you can say beam deflection. And what we want to do is we want to link these to our answers right over here, okay? So these are for the different pieces of wood, beams A through F, A, B, C, D, E, F, okay? So you can see for the moment of inertia for the first beam, it's 20.8. For beam B, it's 1.5, which is here. Beam C, which is a 2x8 set vertically, our moment of inertia is 47, which is right here. So the way we're going to do that is we're just going to click in the cell, and we're going to hit the equal sign, and then we're going to come over here and just click on that and hit return. You can do equals, click on this one, hit return. Okay, that's all I've done for each one of these. And then same thing for beam deflection, we can hit the equal sign and come over here and just click on that one to go with our 20.8. This is the Y, or excuse me, we're doing beam deflection. So moment of inertia will be our X and this will be our Y. You can just come along here. So our beam deflection for the moment of inertia for the second beam is going to be 6.66. So we can just say equals and click on this. Okay. Then the last thing we can do here is we can just highlight these two rows and columns. We can come up here and say insert chart. Okay. And you can see it's basically done everything for us, right? I mean, how great is this? And basically what you want to do over here in this chart editor, you want to select chart and go down and select the scatter plot, which is right down here. Okay. And that's going to give you this. And if you ever want to get that editor back, you can just double click on your graph. But if you get the setup and you get customize, okay, moment of inertia should be your x-axis, okay. But if it's not, you can just come in here and click this and say edit and just highlight those cells. And you can go beam deflection as your series. And again, you could go edit and just come in here and highlight these if you want. Okay. And then the last thing we're going to do is we're going to come into customize. We want to create a line, a trend line for this. And it's going to be parabolic. So we can go to series. And we can come down here and we can do trend line. Okay. So we're in series. We're in the beam deflection. All right. That's our one series. We can check the box for trend line. And then it's not linear. It's going to be a power series. Okay, and you can see here it's a nice parabola, fitting the data very nice. Okay, and at the end of the day here, you have your graph. You can click on it once to highlight it and then click and drag to move it around. And really what you're going to see here is the relationship. At the end of the day is what we want. There's a question on the beam deflection lab which says, after you've plotted it, moment of inertia and beam deflection are inversely proportional, meaning that their product is constant. The graph will form a hyperbola. You know, as we look back at our graph, what we're trying to understand is as the moment of inertia goes up, in other words, let's look at our 2x10, which is our strongest beam set vertically. Moment of inertia is our highest here, 98.9. That means it's very strong. Its moment of inertia is based on its vertical orientation. It's the tallest beam. It'll have the biggest moment of inertia, and hence it has the lowest deflection. Whereas if we set a beam like a 2x6 flat, it has our lowest moment of inertia, 1.5, and that means we're going to have our biggest deflection of the beam at 6.66 right here. Okay, so take a stab at this. If you have any questions, especially around this graph, just email me. I could put out a clarifying video after I've got a number of questions. But this is the last video that should get you basically this worksheet with all these tables. And you don't need to do the bamboo beam testing because we didn't have a chance to do that. And you'll have this other worksheet called table and graph, and that's it. Okay. Good luck, and again, just email me with questions and I'll get back to you.